wanted to track down their topic.
Organ transplantation.
Okay, thank you.
Good to go. All right, please welcome the bioprinting organ transplantation.
Good morning, everyone. This presentation is on bioprinting, made by myself, Grace Hopkins, Emily Baker, Morgan Milburn, Catherine Stowell, Harrison Lee, and Kayla Chapman. Three-dimensional printing of functional organs was an idea generated by Charles Hull. This concept began with the invention of stereolithography, a type of printer that uses lasers. However, printing wasn't made a promising technique until the 1990s, when different 3D systems successfully made organs, or grown. In 2002, scientists were able to grow a working kidney model. It's extraordinary how the aspiration for bioprinting arose from the inkjet printer. What makes this biotechnology so important is its correlation between organ supply and demand. Roughly 1/6 of the waiting list for an organ transplant received one in the US in 2011. The waiting list increases approximately 10% every year. Bioprinting perceives to be a promising technique in the near future. Current improvements in 3D system design software proves a favorable position for bioprinting.
I'm Emily and I'm doing current actions and I don't know how to work a microphone. Currently, government, scientists, and the public are working on successfully transplanting donated organs. Very few are focused on bioprinting. Although very few are focused on it, it has great potential. And part of the reason that people aren't focused on it are because they have fears of rejection and failure of synthetic organs. However, these fears are negligent because our process makes rejection rates lower and is already working in mice. There's thyroids put in mice and all of them are doing well.
Bioprinting is a very innovative and expensive method of organ transplantation. The estimated cost of this method is around $30 million. I know that sounds like a lot of money, but we really need it. And we need it's worth your, it is worth the, excuse me, it is worth the cost because it can save many lives and is really going to advance science technology in the world of organ transplantation. The way this process works is scientists take samples of cells from a human's organ that's not working and produce a fully new organ that will function correctly. So now, because this is produced from a person's organs, it will not be seen as foreign to the immune system, so the immune system will not try to attack the cells in the organ. Also, this is much better than the current modes of organ transplantation because you won't have to worry about finding a new donor and then transporting the organ to.
Our goal is to bioprint and transplant a functioning human kidney by 2020. Kidneys are the most needed and possibly the least available of the organs for transplantation. And this shortage can lead to terrifying issues like the black market. If we're given the funding, we're going to send it to our researchers at the Bioprinting Solutions Company. Right now, they're in the process of bioprinting human kidneys, and they hope to be finished by 2018. Our goal of transplanting those by 2020 extremely feasible.
So a lot of you are probably thinking, okay, so bioprinting would solve a lot of problems with organ donation. But $30 million, which is what we need for this to be a feasible goal, is a lot of money. where is all that money going? And about 70% of that is going to equipment, and it's going to go to facilities, because you need a lot of very expensive equipment to bioprint, because it's a very new field and you have to design a lot of it yourself, and it's going to cost a lot of money. But the money we would get from any grants we got today would go directly into research. What does that mean? That means facilities, that means equipment, and that means raw materials. And all of that would go directly to our research team in a state-of-the-art research lab just outside of Moscow called Skolkovo. And I know Russia sounds pretty sketchy, but it's the best research facility for bioprinting in the world. Okay, and then also, this is a lot of money. When are we going to see tangible results? And right now, we're projecting being able to make a human kidney by 2018. That's not by our goal of 2020. So with the $30 million that we hope to get to funding, would hopefully expedite that process, help us get into animal testing much quicker, and be able to get bioprinted kidneys out into the world much faster. So $150,000 or about there is not a lot compared to 30 million, which is what we need. So we're going to go to a lot of other sources, but the top three are going to be the Russian government, which has started a large initiative, scientific initiative called the Mendev Initiative to modernize Russia, and it does not have a central organization like the National Science Foundation here in America, but there are many small organizations that we hope to get grants from. We're going to go to private investors who are very helpful in trying to get this innovative, potentially amazingly beneficial product, a technology, to the world. And we're going to go to the Bill and Melinda Gates Foundation. Now, some of you may know that Bill will not give grants to people who are trying to solve medical problems in the first world. And it's kind of, the way we've been spending it, it sounds like it's really only going to affect you, the average Western first world citizen. But it's going to affect people in impoverished nations and third world nations. It's going to help you. It's going to take care of the supply and demand problem, which has created all of the problems in regards to organ transplantation. Such as there are villages in India where 1 in 3 adults have had a kidney removed and sold in Western black markets. And this would take care of the demand problem that's been causing them. It would also make organ transplantation available to many poorer people, and because it is more effective, it is cheaper, and it is safer, because of the raw materials are very inexpensive, and once the technology is like up and going, it'll be pretty inexpensive, and because the tissue comes directly from the person, which is why we say. And for conclusion,
organ transplantation is a fairly recent technology and is becoming more well known. The creation of kidneys, which are among the most needed, and other organs through this method will prove beneficial to society. If funded, bioprinting has the potential to save many lives and will resolve a number of problems, including organ trafficking and, most importantly, the higher demand than supply. Thank you for your time, and we will now answer any questions.
you back then. Because most of the organ rejection problems come from the foreign antibodies and the foreign proteins on stuff in the organ, and if it's taken directly from your tissue, your body will not register that as foreign. So most of the what? It's usually taken from stem cells, I believe. Yeah, the stem cells.
Does bioprinting, the company, does that already exist,
Uh,
or are you?
Yes, they developed a fully functioning thyroid a couple months ago, and they already exist, yes. I need to, their website's in Russian. It's not great. Yes.
So you mentioned stem cells. Do you have any idea of how to get adequate supply?
I don't know. I just know the rules for stem cells are not as restrictive as they are here in Russia.
What was his question?
I believe that we wouldn't keep our own supply of them, but they would be individualized for the person to help with the immune rejection. So the person that's getting the transplant.
All right, guys, we're going to take